Hello, this is Transhin Biotech. Today, let's see the operation of the Micro-Spectrophotometer TSS-200. The package mainly includes the main unit, power cord, USB flash drive, and the cuvette slot, upper and lower bases, and a touchscreen. The side panel includes the power input, USB port, and power switch. After connecting the power supply, lower the upper base and turn on the power. The instrument will automatically enter a self-check program. Once the self-check program is complete, the main operating interface will appear. The main interface is divided into three sections. The left section is the functional panel, which includes the operation for nucleic acid concentration detection, protein concentration detection, full wavelength UV-Vis detection, and OD600 detection. Protein measurement is available in two modes, A200 protein detection and colorimetric assay. The middle section is the peak display area, which shows the absorbance of the sample at different wavelengths. The right section is the data display area, which shows the specific measurement results of the sample. Next, let's go through the detailed steps. First is the nucleic acid concentration detection. Click DNA or RNA and select Detection. On the interface, select the type of nucleic acid to be measured. For example, choose DNA 50 for double-stranded DNA. Users can rename the project and ID according to needs. In this example, the default project and ID are used. Before use, the upper and lower bases should be cleaned once with nuclease-free water. Add 2 ml of nuclease-free water to the center of the lower base. Add the liquid to the center of the detection area on the lower base, ensuring it evenly covers the surface. Lay down the upper base to form the liquid column. Lift the upper base and use lens paper or a dust-free cloth to wipe off any remaining liquid from both the upper and lower bases. Before measuring the sample, a blank calibration should be performed. The blank solution is typically the buffer or water used to dissolve the nucleic acid, and its purpose to eliminate background absorbance that may affect the accuracy of nucleic acid detection. In this case, nuclease-free water is used to dissolve the nucleic acid, so it will also be used as the blank solution for calibration. The procedure is shown as follows. After cleaning, add 2 ml of nuclease-free water to the center of the lower base. Add the liquid to the center of the detection area on the lower base, ensuring it evenly covers the surface. Lay down the upper base to form the liquid column. Click the blank button to perform the blank calibration. Usually, blank is valid within 30 minutes. After 30 minutes, it's generally recommended to perform a new blank calibration to ensure measurement accuracy. For nucleic acid detection, 0.5 to 2 ml of sample can be used. Within this range, a larger volume makes it easier to form a liquid column, reducing the precision required during operation. The volume of nucleic acid solution used for detection can be determined based on the sample amount. In this demonstration video, 2 ml is used for detection. Click the sample button to begin measurement. After the measurement is complete, the peak graph and detection data will appear in the middle in the red section of the interface. To save the spectrograph, click the Spectrum button. If you have multiple samples, you can turn on the auto detection option. Within this turned on, the instrument will automatically measure the nucleic acid concentration each time a new sample is added and the upper base is laid down. After measuring each sample, use lens paper or a dust-free cloth to wipe off any liquid from the upper and lower bases before proceeding to the next sample. Insert the USB flash drive into the instrument. Click the DNA RNA button, then select Data from the pop-up menu. Here, you can view previously measured data. Check the data to be exported. Click Export Data, enter the file name, and click Sure to export the data to the USB flash drive. The operation, detection, and data export interfaces are similar to those for nucleic acid detection. Click the protein and select Detection. On the interface, select the sample type to be measured. Here, we take a standard protein mixture as an example. Choose 280. Users can rename the project and ID according to the needs. After cleaning, a blank calibration should be performed before sample measurement. The blank solution is typically the buffer or water used to dissolve the protein, and its purpose to eliminate background absorbance that may affect the accuracy of protein detection. In this case, nuclease-free water is used to dissolve the protein. The auto-detection and data export procedures are the same as those used in nucleic acid detection and can be referred to that section. Common methods for protein quantification using colorimetry assays include BCA, Lowry, and Bradford. Colorimetry protein detection requires construction of a standard curve. The BCA method is used as an example in the following demonstration. The first step is to construct a standard curve. Click the colorimetry function area and select Curve. Click the drop-down menu next to Type and select BCA 562. Click the New Curve button in the pop-up dialog box. Select the curve type. Here, we chose first water. Enter a name for the curve and click Sure. Next, click the selection box under Sample. Here, we chose nanogram per milliliter as the unit. Enter the standard sample concentration sequentially. Up to 10 standard samples can be set. Add a blank sample. Click Blank to perform the calibration. Select the corresponding standard sample. The selected sample will be highlighted in blue. Add the standard sample at the specified concentration. The instrument measures the absorbance of the standard sample in sequence. Each standard sample's absorbance can be measured up to 5 times continuously, and the average value is used as the data point for the standard curve. For multiple replicates, measure the absorbance for each replicate accordingly. In this example, 2 replicates were prepared, so 2 absorbance values were measured. The absorbance of the other standard sample is measured following in the same procedure. Users can delete the standard sample by long-clicking the standard sample name or other area of the line. After all standard samples detected, click Save Curve. Note: new curve must be saved before you choose from drop-down list. Click the Display Curve button to view the details of the current standard curve. This allows evaluation of whether the curve meets the required criteria. If it does, sample measurement can proceed. Click the colorimeter in the main interface and select Detection. Choose the standard curve that was just created and saved. Users can rename the project and ID according to the needs. In this example, the default project and ID are used. Set the type to BCA 562. Before measuring the samples, a blank calibration should be performed. Add the blank sample. Click blank to perform the calibration. Add the sample for measurement. Click the sample button to measure the protein concentration. The Lowry and Bradford method follow similar procedures to the BCA method and will not be described here in detail. Data export can be performed as described in the nucleic acid detection section. The UV-Vis function allows the instrument to operate like a conventional UV-Vis spectrophotometer, measuring the sample absorbance in the 180 to 910 nanometer range. The instrument automatically selects the optical path length based on the absorbance range of the solution. It can detect absorbance values up to 300, equivalent to a 10 milliliter path length. Click UV-Vis on the main interface and select Detection. Users can rename the project and ID according to the needs. In this example, the default project and ID are used. A specific wavelength can be entered in the input box as needed. After the sample measurement is completed, the absorbance and the specified wavelengths will be displayed. Note: the wavelengths must be entered before the sample is measured. Changes made afterward will not take effect. Before measuring the sample, a blank calibration should be performed. Add the blank sample for calibration. Click blank to perform the calibration. After that, add the sample for measurement. Click sample to start measurement. The absorbance of sample cross the 180 to 910 nanometer range will then be displayed. Data export can be performed as described in the nucleic acid detection section. OD600 refers to the absorbance of a solution at a wavelength of 600 nanometers. One important application is using bacterial absorbance to measure the concentration of bacterial cultures, thereby estimating the bacterial growth. Click OD600 on the main interface and select Detection. Users can rename the project and ID according to the needs. In this example, the default project and user ID are used. Before measuring the sample, a blank calibration should be performed. For this measurement, a cuvette is required. Add 2 to 3 milliliter of blank solution into the cuvette, following the placement method shown in the video. Click blank to perform the calibration. After completing the blank calibration, add 2 to 3 milliliter of the sample solution into a new cuvette and place it into the measurement chamber. Click Sample to start the measurement. The measurement results are displayed on the right side of the interface. Data export can be performed as described in the nucleic acid detection section.